Thank you very much. So yeah, I am James Snell. I am on the Node Core team, involved with the CTC, the TSC, a bunch of little acronyms. Basically, it's the team that just focuses on Node full time. I'm very happy that IBM pays me to work on Node every day. I get to have my hands in the code all the time. And this is actually one of the first talks in about a year and a half, 2 years, where I just get to talk about code I've been writing for the past couple months, which I'm super excited about. I don't have to talk about organizational stuff, which is fantastic. So I've been looking at implementing HTTP2 for Node. And there's a number of reasons why we're looking at this. Part of it is just kind of the relevancy of the platform, keeping up to date with the standards. The one thing that I will make clear right from the very start is that there's been no final decision yet on the part of the core team that HTTP2 will absolutely get into core. A lot of the effort right now is deciding, trying to figure out if we were to do this, what would it look like? Like, how would it operate? What are the issues involved with actually doing an implementation? We do have a working prototype, which I'll talk about, and it assumes that it's going to be in core, right? But we could just as easily take it out and put it out as a native module out on NPM as well. We just have to figure that out. So a big part of the discussion right now is getting feedback from the ecosystem on what the requirements should be. And how we should actually, move forward with this. So just keep that in mind. So Node always has been primarily a platform for web application development, and this is the primary argument for why we would do this, right? HTTP has always been an integral part of what Node is. Getting HTTP2 support in there is something that just makes sense from that point of view. Even though Node has this small core philosophy, it doesn't have a standard library really that ships with it. The one thing it does have is that HTTP library, right? HTTP2, it's an evolution of what's already there, but and like I said, it could be a standalone module. But there are a number of things to keep in mind. HTTP1 support in Node right now is very, very specific to that protocol. If you look at the internals, you'll see, in the response object, where when you write data out, it's going directly out to the socket, right? If you look at the HTTP parser that we use, it's very finely tuned to parsing the text-based protocol that HTTP1 is, and it's very difficult to repurpose the existing code to support HTTP2, and I'll get into a little bit on that as to why that is. HTTP2 is an extremely different protocol. If you look at the spec, it keeps the semantics of HTTP2 request and response. And you have the headers and the body and your status codes. At the semantic layer, they've preserved as much as they could. But if you look at the actual the transport layer, what's actually going out over the wire, HTTP2 switches to a binary framing. So instead of using, line delimited text to say, okay, here are here's their preamble, here are the headers, here's the body, right? What it does is it fragments the protocol control data and the request and response payload data into distinct binary frames. Each frame has a header and a payload. The header is something like 9 bytes. It has what kind of thing this is, what the size of it is. There are some flags that are there, and then there's the payload. And what this allows us to do is multiplex multiple requests and responses at the same time over a single connection. So with HTTP1, we've always we've had this ability to pipeline requests. So you can basically queue up multiple requests, and you have to process those in a particular order and wait for the responses to come back in the same order. And we end up with what's called a head-of-line blocking issue, right? And it's a major performance bottleneck when you're actually using pipelining. With HTTP2, we don't have that issue because of the binary framing. It's specifically designed to allow multiple request and response flows to be in flight simultaneously without any head-of-line blocking. And this is accomplished by fragmenting the data and using a priority queue to basically determine which bits are going to be sent over the wire at any given time. okay? So it's a very different protocol under the covers. There's also other things that HTTP2 adds. Stateful header compression is a big one. In order to reduce the amount of header bytes that are actually sent, each side of an HTTP2 connection maintains a state table of what headers have been sent previously on that connection. And instead of like resending the cookie or any of the headers, it will just say, use the one I sent before, right? And we're gonna, that one is still in effect, so just assume that that one is still being used. But what that ends up meaning is that HTTP1 is a fully stateless protocol, right? HTTP2 is not. With HTTP2, sockets are long-lived. You have header state, you have priority state, you have flow control state. A significant amount of additional stuff that's being kept around for a longer period of time for this connection. There is stream prioritization, flow control that operates independently of the TCP level flow control and prioritization. There's new extensibility mechanisms and new features such as push requests and these kinds of things that also have to be looked at and taken into consideration. The bottom line is that there are a lot of new constraints, right? And I just kind of went through some of these. I tend to not follow slides very well, so I'll skip ahead if I do, it's just a thing. A lot of new constraints that HTTP1 currently doesn't have to deal with in Node, right? If you look at the HTTP1 implementation in core right now, we have the HTTP parser, we have the incoming HTTP response, outgoing response. And the user code essentially, when it's writing data, it's essentially writing it directly out to the socket, right? It's a very streamlined, very highly efficient process. With HTTP2, it gets much more complicated. And we have these abstractions of an HTTP session and an HTTP stream, and there's multiple streams per session. There can be millions of streams per session. And what we end up having to do, instead of allowing the user code to write directly to the socket, we have to completely isolate that socket and buffer the data that's being written and read to and from the user code, right? So there's a lot of additional work that's happening under the covers for HTTP2 that Node would have to manage here. Same thing on the client side. On the client side, you open it up, you can't write directly to a socket and expect it just to work with HTTP2. So you can't just open like a telnet session, for instance, right, and test your HTTP server. You have to have the protocol mechanisms in place, and you have to follow this sequencing, this priority sequencing of which frames are being sent at any given time, flow control, all that kind of thing. So the goal in the implementation, what all of this basically means is we have to write brand new code within Node to handle all this. We cannot use any of the existing HTTP1 code in Node to support HTTP2. It's a brand new protocol, it's a brand new code path, and that's what we're basically working on. The idea is to have two distinct supported API levels, and I'll kind of get into this a little bit. There's going to be a low-level API that allows us to work with the sessions and the streams directly without the HTTP request response semantics. The reason for exposing this is that there are people who are wanting to build on top of the HTTP, the framing protocol, but have it be other things other than HTTP, like alternatives like WebSockets or variations on push streams, and there's other things people want to be able to do with this, and we want to enable that people to do that kind of stuff with Node as well. We also want to have the high-level HTTP specific API that is modeled very closely after what users have in Node today with HTTP1. So you'll have the request and response objects. You'll have HTTP2.create server, right? Very similar to what users are doing today. In order of priority, though, the things that we're really looking at, we need the performance and security to be there, right? And there's a lot of new things that are happening in the protocol that we really have to look at. It's going to take us a while to get this right. So we need to be patient with it. Expected API compatibility is a huge question. How close do we have to have this work to the compared to the existing API, right? Is it okay for us to break, right? Not the existing code which is left untouched. Like I said, it's a brand new code path, so any existing code continues to work. But does HTTP2 need to work like HTTP1 in core, right? Is that what users need? We're still trying to figure out, tease out those questions. the lowest priority is actually exposing the new features. Like if we cannot reasonably deliver the good performance or have a good API experience for users by delivering, having these new features, then we'll delay exposing those new features. So push streams, may have to wait while we work on everything else, right? Majority of the heavy lifting falls on the ng HTTP2 library. So if you're not familiar with this is the same HTTP2 implementation that's used by curl and quite a few others. It is hands down the best implementation of HTTP2 out there. It is extremely well tested. It does almost all of the heavy lifting for us in terms of the state management. All we have to do is take the data off the socket, pass it to ng. It does most, all of the parsing, all the state management, and then it calls some callbacks for us to tell us like what kind of headers we got and what kind of body, what our data is. So all we have to deal with are the callbacks on that. Works really well with libuv, really well with the existing architecture of Node. I apologize if this is kind of difficult to read. This is kind of a high-level view of the architecture. We're going to have an internal native layer, which is where most of the work is happening. And that is going to be exposed through the process bindings. It's going to be like a process binding on HTTP2. Typically, those are unsupported APIs in core. These are the things that Node itself depends on. And then there's going to be a bunch of stuff written out in JS, which is the higher level, the higher level APIs that users will rely on and build on. Okay, it's actually quite similar to the way that HTTP is currently structured in Node. It's not a huge departure. It should be very familiar once we get down this path. So quick example. Like I said, we have a working server right now. We're still working on the client bits. But the server itself is very similar to what Node users already do, right? So instead of require HTTP and leaving it at that and then doing HTTP create server, it'll just be create secure server or create server on using HTTP2 module. Now, this create secure server is interesting. HTTP2, the spec does not require TLS, all right? But the client implementations in Chrome and Firefox, the browsers, they require TLS. They will not connect to an HTTP2 server that is not secured with TLS. So it becomes a practical requirement. The default position is just, it's a secured connection, right? And there are a number of reasons for that, but what this basically means is, in Node, the server will, by default be a secure server, right? You will be able to create a plain text, but that's not going to be the recommended path. But it's very similar, and this boils it down just to the basics. Like I said, push stuff gets a lot more complicated. So for this is API is temporary, but just create a push stream and push those things out. If we look at performance, and this is just a peak load benchmark, 100,000 requests as quickly as possible to the server. Spread across 50 clients, eight worker threads, right? The existing HTTP1 implementation was able to do 21,000 requests per second under this test. But the caveat of that is that there was a 15% failure rate. 15% of the HTTP1 requests just simply were not served by Node. And this is like with no changes to what's in Node Core today. So, 21,000 requests per second, yes, but 15% failure rate is pretty high. With the HTTP2 implementation, that's the third column right here, we're able to get about 18,000 requests per second, but 100% success on those. So we're handling more concurrent transactions, slightly less transactions per second. The second and fourth columns is if we're using cluster. This tiny little blip right here, just by comparison, if you go out on NPM today, there is the HTTP2 module that's out there. It's a pure JavaScript implementation of the protocol. Running this test, I was able to get about 250 requests per second. Slight difference. This is the motivation for why getting into the core with a native implementation is really important. If we're going to go down this path and really take it seriously, this is why we're doing what we're doing. Oh. Docker. Okay. All right, so if we look at more on the performance profile, header compression, why are we doing this, right? 5 minutes left. So this is the orange column is the total number of bytes sent on an, through this test, right? In the first column, we see with HP1, it's a very chatty protocol, right? When you're sending a lot of headers, there's a lot of duplication in these requests. A lot of the same headers sent over and over and over again, right? And it doesn't matter if it's cluster or whatever. There's some variances there. The third column shows the tiny little blip of gray, on the third cluster. That's the header data that was sent in this test for HP2, right? Because essentially we send those headers once, and then we're just reusing them over and over and over again, right? Whenever there's a duplication, we're saving a significant, something like 90, I'm thinking like a 96% savings in just the amount of header data being sent, which is significant. So there is a trade-off with using stateful header compression, introducing state into the protocol, but we're using that connection far more efficiently than what HP1 can currently do. Again, this just speaks to the motivation of why we would do this. It will make using HP2 in Node, or using HP in general in Node, far more efficient and allow us to do more with a single instance, right? Just some details on that. With HP1, we were using Keep Alive. And like I said, there's 96% savings in the data, header data. These numbers, this is a development image. Like I've been working on this for 2 months. There's a lot of optimization that can be done. So we need to just continue to optimize this. There's a lot of things in the pipeline. Like I said, there's a lot of buffering that needs to happen. So as we're going through this, we need to optimize, and hopefully the numbers will continue to improve. My goal is to get the transaction rates, requests per second, equivalent to what the HP1 is. So I want to see 21,000 requests per second out of this benchmark with HP2 when I'm done. There is a ton of stuff to do still. There's, HP2 has upgrade mechanisms where you can basically run HP1 and HP2 on the same port, right? And you negotiate which one you're actually using. There's that. There's client work, which I'm very happy to say Google is jumping in to help with some of that. Performance optimization, performance testing. There's all kinds of stuff. So please, if you have an interest in this, come help. We have the repo Node.js HP2. It is a clone of master of Node Core. I'm doing this as a separate code stream right now because the decision hasn't been made whether this will definitely get into Core. I'm doing it this way so we can at least get a build. We can get development images with this support in there and play around with it and develop it. So I would love additional eyes on this and folks helping out. And that's it. I am J.A. Snell everywhere: Twitter, GitHub, Gmail, my IBM email. It's just J.A. Snell. So I'm really easy to find. Feel free to reach out. And that's basically it. We got a minute and a half if anybody has any questions.
Got a microphone for you.
So I'm not a REST API expert or HTTP2 expert or anything like that, but just curious, have you delved or thought about the high-level implications of HTTP2 on REST APIs and stuff like that?
Yeah, so initially, while the protocol was being put together, I had a lot of skepticism about, how much of a benefit HP2 would actually have for REST APIs, and it turns out that it actually makes things far more efficient. Since you're using that connection more efficiently, you're able to send a higher rate of requests, and if we're talking about, fairly small REST style requests. You're able to maximize your bandwidth and your efficiency of actually serving those up and responding to those. And the ability to multiplex and push streams in particular offer some really interesting new possibilities for how some of those REST APIs can be developed. So it's going to take some teasing out, but there's some really interesting things there. So, we have time for one more question back there.
So with my current understanding of HTTP2, I'm going to assume that SPAs are going to increase in usefulness because of the ability to utilize the streams. Do you agree with that statement? Do you think we'll see an increase?
Yeah, I think that there is still a lot to be proven out about the protocol, right? And it's going to be a while before we can really say, what aspects of it are really going to have a positive impact and which aspects are just going to be a pain to deal with, right? So it's still very, very young, very mature, but I think we're heading in the right direction for that kind of stuff. So, okay. Okay. So, another question?
Yeah, on your graphs, I know you said the performance was, early on, it's going to change. But obviously, HTTP2 looks slower. It was using less data, but requests per second were slower.
Right.
Is that because those experiments were just sending requests the same way HTTP1 does and not using these like stream or push? Do you expect that you're going to need to leverage those additional features in order to surpass the RPS of HTTP1?
So in this particular test, it was basically just, let's see how many gets we can do like concurrently. On the HTTP2 test specifically, I was basically throwing, I think per client was 12,500 concurrent streams over a single socket, right? Just happening all at the same time. The performance bottleneck happens in the context switching that has to happen between processing the individual data frames for those individual requests. You have control data frames like the header frames. You have the data frames themselves. You have flow control. There's prioritization. Things are happening. Each one of these, managing the context switching that has to occur when you're multiplexing all of those introduces an additional bottleneck that like Node currently doesn't have to deal with HTTP1. And that's really where the performance hit is occurring. We can tune the performance based on the number of concurrent streams that can be opened at any given time. So if I say the max is 100, we get a much different performance profile than when I say the max is 12,500, right? And it really comes down to how quickly your server can process the individual frames of data. And that's the part that we're working on optimizing right now. So hopefully that answers the question.
Yeah.
Okay. All right, thank you.